Imagine a future where you slash your hot water bills, shrink your home's carbon footprint, and say goodbye forever to the fear of cold showers, all because of a single, intelligent device humming quietly in your basement. This future is no longer a distant dream. General Electric, a name synonymous with American innovation for over a century, has just unveiled a radically advanced heat pump water heater that could overhaul not only the way we heat water, but the very economics of home energy. But does this new Geospring truly represent a revolution? Or is it just another high-tech promise that may fall short under real-world pressure? Today, we will dive deep into the technology, history, market forces, and the risks and opportunities this device brings, not just for your home, but for our entire energy system. Let's start by rewinding the clock. For almost a century, homes across the United States and around the world have relied on two basic types of water heaters: electric resistance tanks and gas-fired heaters. Both have been tried and tested, but both are, frankly, relics of another era. These conventional heaters are essentially energy-hungry metal barrels. Electric models work like giant kettles, using metal coils to heat water, while gas versions burn fossil fuels, releasing both carbon dioxide and other pollutants. According to the Department of Energy, water heating can account for as much as 1/5. Yes, that is roughly 20% of a typical household's total energy consumption. That means, for every $5 spent on home energy, at least $1 goes just to heating water for your showers, laundry, and dishes. Multiply that by tens of millions of homes, and you begin to see the staggering scale of energy and money being consumed. The environmental impact is massive. In the United States alone, traditional water heating contributes hundreds of millions of tons of carbon dioxide emissions annually. That is equivalent to the emissions from millions of cars on the road. The urgency to find a better way is clear, especially as climate change accelerates and both governments and consumers look for solutions that are cleaner, more efficient, and future-proof. The story of heat pump water heaters, or HPWHs, begins decades ago. While the underlying heat pump principle has been used in refrigerators and air conditioners since the early 20th century, applying it to water heating was a slower journey. The core idea is elegant. Instead of creating heat by burning fuel or passing electricity through coils, a heat pump extracts warmth from the surrounding air, even when it feels cool, and transfers it into the water tank. This process requires much less energy because it moves heat rather than generating it from scratch. In laboratory conditions, HPWHs can be 2 to 3 times more efficient than standard electric or gas heaters. In practical terms, that can mean cutting your water heating bills by half or even 2/3, depending on your local climate and how much hot water you use. But despite these advantages, heat pump water heaters have faced a difficult road in the United States. In the 1990s and early 2000s, HPWHs quietly gained popularity in Europe and Asia, where higher energy prices, tighter regulations, and greater environmental awareness encouraged rapid adoption. In countries like Japan and Germany, entire apartment blocks and neighborhoods have used heat pump water heating for years, supported by government incentives and consumer education campaigns. However, in North America, progress was much slower. Early HPWHs were expensive, often costing 2 or 3 times as much as a conventional tank. They could be noisy, required special installation, and sometimes struggled to deliver enough hot water during cold snaps. Many homeowners and contractors balked at the upfront price tag, the complexity, and the risk of trying something new. Recognizing these challenges, the United States government stepped in. The EnergyWise STAR program, launched in the early 2000s, specifically challenged manufacturers to design a heat pump water heater that could meet the needs of American families. General Electric was among the first to answer this call, introducing the original Geospring HPWH in the year 2008. Over the next 7 years, GE iteratively improved the Geospring, gaining a reputation for reliability and efficiency. Yet despite these advances, the broader market was not quite ready. In 2015, General Electric exited the HPWH business, selling its product line to Bradford White and leaving the field to a handful of competitors. But behind the scenes, the world was changing. As nations set ambitious climate goals and utility companies began offering rebates and incentives, HPWH sales in the United States quietly quadrupled. Internationally, millions more households made the switch. In some regions, such as the Pacific Northwest, coordinated efforts by utilities, nonprofits, and manufacturers led to entire communities adopting HPWHs, slashing local emissions and saving millions of dollars in utility costs. Meanwhile, global events, ranging from volatile energy prices to natural disasters, highlighted the vulnerability of relying on fossil fuels and outdated infrastructure. Now, nearly a decade later, General Electric is staging a comeback. Their new Geospring heat pump water heater is not just a minor upgrade. It is the result of years of research, field testing, and feedback from homeowners, installers, and energy experts. Industry insiders are calling it a potential turning point. According to the Department of Energy, heat pump water heaters are a key technology for decarbonizing the residential sector and achieving national energy efficiency goals. The American Council for an Energy-Efficient Economy, a respected think tank, notes, the dual-voltage feature in General Electric's HPWH addresses a critical barrier to adoption by simplifying installation in diverse home setups. So, what exactly sets this new Geospring apart? To start, it is the first model on the U.S. market to work seamlessly with both 120 and 240 volts. Traditionally, if you wanted to replace a gas heater with a HPWH, you would have to hire an electrician to run a special 240-volt line, an expensive and inconvenient process. Now, with the Geospring, you can simply plug it into a standard outlet if you are switching from gas, or use 240 volts for faster performance if you are replacing an existing electric tank. This dual voltage capability removes a major barrier for millions of homeowners, especially those in older houses or apartments with limited electrical capacity. But that is just the beginning. The Geospring comes equipped with an advanced electronic mixing valve, allowing you to safely store water at temperatures up to 160 degrees Fahrenheit, well above the usual threshold for residential tanks. Why is this important? Storing hotter water means you dramatically expand your effective hot water supply. For example, a 50-gallon tank operating at 160 degrees can deliver as much hot water as a conventional 80-gallon tank, because the mixing valve blends in cold water to achieve safe temperatures at the tap. This is a game changer for large families, homes with high hot water demand, or anyone tired of running out during back-to-back showers. Safety is also front and center. Scalding injuries from hot water are a real concern, especially for children and seniors. The Geospring's intelligent valve system ensures that water delivered to your taps never exceeds safe limits, even as the tank runs at much higher internal temperatures. This safety innovation, once reserved for commercial or industrial settings, is now available to everyday consumers. Environmental impact is another area where General Electric has not just kept pace, but leapfrogged ahead. The refrigerant inside the new Geospring is called 1234YF, a state-of-the-art, ultra-low global warming potential refrigerant. Previous generations of HPWHs, like most air conditioners, used a chemical known as R134A, which, if leaked, could have a greenhouse effect hundreds of times greater than carbon dioxide. 1234YF, now required by law in all new car air conditioners across Europe and increasingly in North America, has a GWP rating orders of magnitude lower. This means that even in the event of a leak, the environmental impact is negligible compared to older refrigerants. It is a quiet but crucial step in making these devices truly climate-friendly from the inside out. Efficiency and performance are also dramatically improved. The Geospring features a variable speed compressor, a technology previously found only in high-end air conditioners or one or two competing HPWH models, such as those from LG. Unlike fixed-speed compressors that operate at full blast or not at all, a variable speed compressor can ramp up or down based on real-time demand. This translates to faster recovery times, less energy waste, and an astonishingly quiet operation. Just 41 decibels, quieter than a typical conversation. Imagine running your water heater in the basement or utility closet and barely knowing it is there. General Electric has also focused on user experience and connectivity. The Geospring comes with a wireless leak detection system, a compact sensor you can place anywhere in your home. If it detects even a small amount of water, it sends an instant alert to your phone, helping you prevent costly water damage before it spirals out of control. This is particularly valuable given that water heater leaks are a leading cause of home insurance claims, often resulting in thousands of dollars in repairs. The smart app that pairs with the Geospring brings your water heater into the 21st century. Homeowners can monitor energy usage in real time, set heating schedules, and even receive maintenance reminders or software updates directly to their devices. Imagine getting a notification when your energy usage spikes, or being able to remotely lower the tank's temperature when you are away on vacation. As homes become smarter and more connected, these features are no longer just nice-to-haves. They are rapidly becoming the standard for new appliances. But as with all major innovations, the road ahead is not without its challenges. As HPWH adoption accelerates, new and sometimes unexpected questions are emerging. One of the most pressing is the impact on the power grid. Imagine millions of homes, all upgrading to highly efficient, but electrically powered, water heaters. While each individual unit may use less energy overall than a gas or resistance tank, the cumulative effect can be significant, especially during peak demand periods, such as cold winter mornings when everyone is showering at once. Some energy analysts warn that if grid infrastructure upgrades do not keep pace, we could see localized brownouts or surges in electricity prices, at least in the short term. This is particularly true in older neighborhoods or regions with already overstressed electrical systems. The next frontier is cybersecurity. As these appliances become smarter, connecting to home Wi-Fi networks, utility company servers, and even electric vehicle chargers, new risks emerge. The American Council for an Energy-Efficient Economy has flagged cybersecurity as a frontier risk, a challenge that manufacturers, utilities, and regulators must confront head-on. Imagine a scenario where a hacker gains control of thousands of water heaters, turning them on and off remotely, or worse, manipulating settings to damage equipment or spike energy bills. While such attacks remain rare, the potential for disruption grows as more devices come online. General Electric and other leading manufacturers are investing heavily in encryption, secure software updates, and user education. But experts caution that vigilance will be needed as the smart home revolution accelerates. Yet the opportunities presented by smart, connected HPWHs are equally profound. With artificial intelligence on the horizon, future models could learn your daily routines, adapting heating cycles to maximize efficiency and comfort. For instance, a smart water heater might coordinate with rooftop solar panels, heating water when the sun is shining and electricity is free, then ramping down at night. Or it could communicate with the local utility, participating in demand response programs that help balance the grid and lower your bills. Some utilities already offer rebates or discounts to customers who allow their HPWHs to be remotely adjusted during peak periods, providing a win-win for both consumers and the energy system. The dual voltage feature, hailed as a breakthrough by the ACEEE, is especially important for adoption in diverse home setups. In older homes, or those transitioning from gas to electric appliances, rewiring can be a major barrier, both financially and logistically. By removing this hurdle, General Electric is opening the door for millions more households to join the clean energy transition, regardless of their home's age or layout. Let's not overlook the broader economic implications. As HPWHs become more common, economies of scale will drive down costs, making these devices accessible to more families. According to the Northwest Energy Efficiency Alliance, HPWHs are already a cost-effective solution for reducing energy consumption and lowering utility bills. With utility rebates, federal tax credits, and state-level incentives, the upfront price gap between HPWHs and traditional tanks is shrinking rapidly. In some regions, households can receive more than $1,000 in rebates simply for making the switch. Over the lifespan of the device, often 10 to 15 years or more, most homeowners will not only recoup their investment, but save hundreds, if not thousands of dollars. There are also job creation and economic development angles. As demand for HPWHs rises, so too does the need for skilled installers, electricians, and maintenance professionals. Training programs are springing up in community colleges and trade schools across the country, preparing a new generation of workers for the green economy. Manufacturers are investing in domestic production facilities, creating high-quality jobs and strengthening supply chains. The ripple effects extend far beyond individual households, boosting local economies and fostering innovation. So what does all this mean for you, the homeowner or renter watching today? The arrival of the new Geospring signals a pivotal moment in the evolution of home energy technology. For the first time, you do not have to choose between economic savings and environmental responsibility. With features like dual voltage compatibility, a variable speed compressor, advanced mixing valves, and smart connectivity, HPWHs are now quieter, greener, and more convenient than ever before. If you are considering replacing an old water heater, especially if your current unit is more than 10 years old or showing signs of wear, now is an ideal time to explore HPWHs. The benefits are clear. You will likely cut your water heating bills by more than half, reduce your home's carbon footprint, and prepare your property for a future where energy standards are only going to get stricter. Be sure to research local incentives. Some utilities and state programs offer substantial rebates, sometimes exceeding $1,000, for upgrading to a qualifying HPWH. From a practical standpoint, focus on smart installation and ongoing maintenance. Work with certified installers who understand the unique requirements of HPWHs. Take full advantage of connectivity features. Use the app to track your energy consumption, set personalized schedules, and receive timely maintenance alerts. And do not neglect cybersecurity. Change default passwords, keep your device's firmware updated, and follow best practices for securing your home network. Small steps today can yield big savings and peace of mind tomorrow. What about the future? As HPWHs become standard in new construction and more common in retrofits, they will start to interact with other smart home devices. Imagine a scenario where your water heater, thermostat, solar panels, and electric vehicle charger all coordinate in real time, optimizing your household's energy use and even selling excess power back to the grid. Cities and neighborhoods could, in effect, become miniature distributed power plants, resilient, efficient, and cleaner than ever before. Yet, it is important to acknowledge the challenges that remain. Industry inertia, consumer skepticism, and the need for continued education will not disappear overnight. Manufacturers must continue to innovate, simplifying installation, improving reliability, and ensuring that ongoing costs remain low. Utilities and policymakers have a role to play as well, investing in grid upgrades, supporting workforce development, and designing incentive programs that reach all communities, including renters, low-income families, and those living in older homes. Let's also take a moment to appreciate the global context. As countries around the world race to decarbonize their economies, technologies like the Geospring are part of a much larger story. In places like Australia, Scandinavia, and parts of China, government mandates and consumer demand are driving rapid adoption of heat pump technologies. These international experiences offer valuable lessons. For example, Japan's EcoCute program, which promotes heat pump water heaters using natural refrigerants, has become a model for other nations seeking to accelerate the transition to clean energy. From a historical perspective, the rise of HPWHs echoes previous energy revolutions. Think back to the rollout of home refrigerators in the early 20th century, or the spread of central heating in the post-war era. Each of these technologies transformed daily life, improved health and comfort, and reshaped entire industries. The shift to heat pump water heating could have similar, far-reaching consequences, not just reducing emissions, but changing the way we think about energy, convenience, and sustainability in our homes. Let's revisit that secret fact. The refrigerant inside the Geospring, known as 1234YF, is not only climate-friendly, it is a direct result of international collaboration to phase out polluting chemicals. Its adoption in both cars and now home appliances demonstrates how innovations can leap across industries, multiplying their benefits. Your future water heater could be as green as the latest electric vehicles on the road. In summary, the new Geospring from General Electric is more than just another appliance. It represents a convergence of technological innovation, environmental responsibility, and economic opportunity. It is a device that can help you save money, protect the planet, and future-proof your home, all while offering more comfort and convenience than ever before. So are you ready to make the switch? Or are you planning to wait and see how the market evolves? What are your biggest questions or hesitations when it comes to adopting new energy technologies? We would love to hear your thoughts in the comments below. If you found this deep dive useful, or if you want to stay on the cutting edge of green technology and global economics, do not forget to like, subscribe, and share this video with friends and family. The next revolution in home energy